You ever look at that thick, black crude oil that gets pulled from the ground and just wonder, how in the world does that stuff turn into the gasoline for your car, the diesel for a truck, or even the fuel for a jet? It kind of seems like magic, but nope, it's pure science. And today, we're going to pull back the curtain on the very first, and you could argue the most crucial step in that whole transformation, a process called petroleum distillation. Okay, so let's start at the beginning. What even is distillation? At its heart, it's a really brilliant solution to a pretty big problem. Crude oil isn't just one thing. It's this complex cocktail of thousands of different compounds. And distillation is how we sort them all out. Now, the key word here is physical. We're not doing some wild chemical reaction to create new substances. We're simply sorting what's already there. And we do it by taking advantage of a really basic property. Every single component in that oil has a different boiling point. Think about it like this. When you heat up that crude oil, right? The lighter, smaller molecules, they get all excited and poof, they turn into vapor first. But those heavier, denser molecules, oh, they need a lot more heat before they're going to go anywhere. So by carefully controlling the temperature, you can actually get them to separate themselves. And where does all this happen? It happens inside these absolutely massive structures called distillation towers or columns. Honestly, the best way to picture one is as a skyscraper. But instead of offices on each floor, it has different temperature zones. So let's take a quick journey up this tower. First, superheated crude oil gets pumped into the base, which is the absolute hottest point. The really heavy materials, like bitumen for asphalt, just stay liquid and get collected right at the bottom. Everything else turns to vapor and starts to rise. As it goes up the tower, it cools down, and different components condense back into liquids on these special trays at different levels. So you've got diesel somewhere in the middle, all the way to the lightest gases at the very top where it's coolest. So we've separated the oil into different fractions. Seems pretty straightforward, right? Well, not exactly. To do it really efficiently, the whole process is actually broken down into two distinct stages. It's all about getting the most value out of every single drop of crude oil. And to pull that off, refiners use two different kinds of distillation, one right after the other. So the whole thing kicks off with atmospheric distillation. This happens at normal air pressure, and its job is to separate out those lighter components. What's left over is this thick, heavy residue. That residue then gets sent to the second stage, vacuum distillation. And here, they dramatically lower the pressure inside the tower. This is done for one very specific reason, to avoid destroying the valuable heavy oils. See, here's the problem they're trying to solve. To boil those really heavy oils at normal pressure, you'd need extreme, destructive temperatures. That heat would literally cook the valuable oil, breaking the molecules apart in a process they call thermal cracking. You just end up with this solid, useless gunk called coke that clogs up and damages all the expensive refinery equipment. So by lowering the pressure, you lower the boiling point. It's a clever way to gently separate these heavy oils without burning them to a crisp. So we get the how, but let's talk about the why. Why does this one process matter so much in the grand scheme of things? Because it is, quite literally, the starting point for everything else that happens in a refinery. This quote from our source material just says it all. The naphtha fraction goes to one unit to be turned into gasoline. The kerosene fraction goes to another to become jet fuel. The heavy oils go somewhere else to become lubricating oils. You see, distillation doesn't create the final products, but it provides the essential, sorted ingredients for every other process down the line. And that brings us full circle. By separating that crude oil into these distinct fractions, we create the feedstocks that are eventually refined into all the products we recognize and rely on every single day. It feels like the beginning of the story, right? The crude oil arrives, it goes into the tower, and we're off. But what if I told you there's another absolutely critical step that happens even before distillation can begin? That's right. Before you can separate the oil, you have to clean it. Crude oil comes out of the ground with salts, water, and other impurities that can cause massive damage to the refinery. The process of removing them is called desalting. And understanding that, well, that's a whole other story.